Blockchain technology is like a digital ledger system that tracks and records transactions in a secure, transparent, and decentralized way. To make this more relatable, imagine a public ledger book that records everything, but instead of being stored in one place, like in a bank or a government office, it's stored across many computers all over the world. This is the core idea behind blockchain. Key concepts: decentralization. Traditional systems like banks or governments rely on a central authority to manage records. For example, if you send money through a bank, the bank acts as the middleman and verifies the transaction. In blockchain, there's no need for a central authority. Instead, transactions are verified by multiple computers, called nodes, spread across the network. All these nodes work together to agree on the validity of transactions, making the system decentralized. Why is this important? Decentralization makes blockchain more resistant to corruption or manipulation. Since no single person or entity controls the entire system, it's harder for hackers or bad actors to tamper with the data. Transparency and immutability. Blockchain is incredibly transparent. Every transaction that happens on a blockchain is visible to everyone on the network. For example, if you send some cryptocurrency to a friend, everyone can see that the transaction took place, but they won't know your identity unless you reveal it. Immutability means that once a transaction is recorded on the blockchain, it can't be changed or deleted. This creates a permanent and secure record of all activity. Why is this important? Transparency builds trust, and immutability ensures that data isn't altered. It's like having a history book where the facts can't be rewritten after they've been recorded. This is especially useful for applications where trust is critical, like in financial services, voting systems, or even supply chain management. Blocks and chains. The name blockchain comes from how the system stores information in blocks. A block is a collection of data, usually containing multiple transactions. Once a block is filled, it's linked or chained to the previous block, creating a chain of blocks. Hence the term blockchain. Each block contains the list of transactions, all the activities recorded within a given time. A timestamp when the block was created. A cryptographic hash, a unique identifier that links it to the previous block. Why is this important? Since each block is linked to the previous one, altering any transaction in a block would require changing all the blocks after it, which is nearly impossible in large networks. This adds another layer of security. Consensus mechanisms. In a blockchain, there needs to be a way for all the decentralized nodes to agree on the state of the network, like agreeing on which transactions are valid. This is where consensus mechanisms come into play. Proof of work, POW, the first consensus mechanism used by Bitcoin. It requires miners' computers to solve complex mathematical puzzles to verify transactions and create new blocks. It's secure, but consumes a lot of energy. Proof of stake, a newer and more energy-efficient consensus method where validators are chosen based on how many coins they hold, their stake. The more coins you own, the more likely you are to be chosen to verify transactions. Why is this important? Consensus mechanisms help keep the blockchain secure and decentralized. They ensure that everyone agrees on the truth of transactions, preventing fraud or double spending. Real-world applications. Blockchain isn't just about cryptocurrencies like Bitcoin or Ethereum. It has a wide range of potential uses across industries. Finance and banking. Blockchain can revolutionize the financial industry by making transactions faster, cheaper, and more secure. Instead of waiting days for cross-border payments, blockchain allows money to be transferred almost instantly. Supply chain management. With blockchain, companies can track products from the moment they're made to when they reach the consumer. This improves transparency and helps combat issues like counterfeiting. Voting systems. Blockchain could be used to build secure voting platforms. Since blockchain is tamper-proof, it can ensure that votes aren't altered after being cast, making elections more secure and transparent. Healthcare. Blockchain can store medical records securely, ensuring that patients' data is private and accessible only to authorized individuals, while also preventing unauthorized changes to the data. Challenges and limitations. While blockchain technology is promising, it's not without its challenges. Scalability. Blockchain networks, especially the ones using proof of work, can be slow. For example, Bitcoin processes around 7 transactions per second, which is very low compared to Visa's 24,000 transactions per second. Energy consumption. Mining, especially in proof-of-work systems like Bitcoin, uses a huge amount of energy. This has raised concerns about the environmental impact of blockchain. Regulatory issues. Governments around the world are still figuring out how to regulate blockchain technology. Since blockchain allows for anonymous transactions, it can potentially be used for illegal activities like money laundering or tax evasion. User adoption. For blockchain to become mainstream, everyday users need to find it easy to use. Right now, the technology is still quite complex and not always user-friendly. Conclusion. In summary, blockchain is a revolutionary technology that has the potential to change the way we think about trust, security, and transparency. It offers a decentralized, transparent, and secure method for recording and verifying transactions, with applications far beyond just cryptocurrencies. However, it's still evolving, and there are challenges to overcome before it can fully reach its potential in everyday life. Think of blockchain as the early days of the internet. While it has incredible potential, we're still discovering all the ways it can be applied.